Alright, welcome to my Captivate project. I'll be talking about an experimental design process. The first step is to define the problem statement. Essentially, what are you trying to solve? Whom is being impacted? So is this a manufacturing problem where we have tools that are impacted? Or is it a teaching problem where students are being impacted? Next question is, what will be the impact if this problem is not addressed? This helps to know how much money should be investigated into gathering data. If it's a small impact, then maybe it's just a small amount of data or a small experiment that needs to be ran. If it's a large impact and it's very critical to the business, then that will lead to more data and more money being put into it. Next question is, what are the hypotheses? And what are the responses that we measure to determine success or failure? So hypotheses refer to the response, and they can be written with Greek letters in a scientific format using HO and HA, the null or alternative hypotheses, or they can just be written out in general terms of what response or responses that are going to be looked at as data is gathered. The next step 2, is to define the factors and factor levels of interest. So the factors can be many different things, and they can consist of the things that can be controlled directly, things that can be controlled indirectly, that may be controlled by other variables that are currently not being included in the experiment, and factors that could impact the response but are not controlled, or they can't be controlled. Sometimes as a process runs, there could be some factor or some control knob that is not controlled, like maybe a temperature that we can try to control it, but we can't do it very well. But we do want to record what values that factor took on as the experiment ran, so they could be included in the analysis to help determine different signals. The next step is step 3. This is where you want to choose the experimental design. So standard experimental design is a factorial arrangement. So every possible factor is ran at every other factor level. So essentially every combination of factor levels that may exist. And these designs consist of several different points, or they can have these different points. One is referred to as the design point. There's factorial points, center points, and axial points. Design point is essentially any point that's in the design space. Factorial points are the primary corner points of the design. Center points as it states, it falls in the center. And axial points are the non-corner points of the design to help define what type of polynomials may exist in an algebraic function. So let's look at the following quiz. So it says click on a design point. So I will choose design point and submit. So go to the next question. The following image, click on a factorial point. So I'll click somewhere different. So that's incorrect. So remember the factorial point, as I mentioned, were the corner points. Next question, click on an axial point. So again, just for something different. Again, those are the factorial points. The axial points are the ones that are off the center or off the square of the design for estimating curvature. And then next one is to click on the design space. So remember, the design spaces can be anything, any of the design points, including the points that are not necessarily running in the experiment, because we're using these points to help estimate the function that exists in design space. So I could click anywhere, submit that, and it's the right answer. So then we get our results. And that's all I have. Thank you for listening.